Hello everyone, this is Ahlia Devi Adapa studying in Kavni Institute of Technology and Sciences. My registration number is URK20CS3028. Here is my experimental record work 7 of design and analysis of algorithm. The seventh experiment is about a minimum spanning tree using Prim's algorithm. Prim's algorithm is to find a minimum spanning tree. So now let's see the coding part. This is the code I have written. First, I have created a function called as prims and taken and assigned the characters n, a, q, key, and p as variables. We have initialized these variables, and I have considered key 0 as value as 0 and assigning f is equal to false into n, and I'm getting the length of the queue. If length is not equal to 0, then we'll find the minimum of function q, f, and key, and we'll store it in ind variable. If f of ind is equal to true, then we'll also assign length will be decremented by 1. And we have considered one for loop and nested if statements for getting the key values and p of I and p of ind. So first I have taken I in range of n, and for first if statement we are considering if f of I is not equal to true, and then if it's not true, then we'll go to the next if condition, that is a of ind and I is not equal to -1. Then we'll proceed to another if condition, that is a of ind I is less than key. Then we'll take a key of key at I index will be equal to a of ind and I. So then we'll also consider another condition, that is P of I is will be equal to Q of IND. The value at index I in P and the value of Q in index I and D will be equal. Then we are printing the output over here. We'll print for E in Q values, and then P values, and then key values will be printed there. Then we have also considered one other function called as minimum function for finding the minimum spanning tree. So we have taken one variable m with infinity, and then we have considered one for loop with range of q, and then we have considered two nested if statements. One is if value of uh, mm, value of a variable value of f in index I is equal to false, then we'll take another condition, that is m greater than key of I, that is the value at index I in key values. If it's true, then we'll take m is equal to the value of key at index I. Then and also another condition with x is equal to key of index at m. Then we'll return the x value, and here we are taking the user input, that is number of nodes from the user, and we are printing. We are getting the number of inputs and all, and we are storing the values over here with we'll ask the user how many nodes will be there, and then what are the nodes corresponding to them, and we'll store them over here. We'll store this queue, and we have considered key is equal to infinity, and then we'll print a values. We have considered while loop here for taking the inputs. If we want to exit, we can give the key value -1, or else we'll give c comma d comma w, that is the number of nodes and their corresponding codes. We'll give the node values. C and d are node values, two node values, and w is the cost of the cost between the two nodes. And then if c is not in q, we'll append the value. If d is not in q, we'll append the value, or else we'll consider the cost only. and we'll print this is the formula, and then we'll print the cost of the values, and using the prints we'll the call of the function. So this is the output we got. So here we have considered five. We have asked the user about the number of nodes. They were five, and it asks if you want to exit, enter -1, and I have given only one. So it proceed to another step, and then it asks for the corresponding nodes and corresponding costs. So I have given the values as a, b, comma 1, and then I have not entered anything. So I have given only one. I have given enter. So it asked again, and then I have given all the nodes and their respective costs, and then finally I have exited from the code giving -1, and then my output was printed over here. That is, we have considered the we have taken the nodes, right? That is a, b, c, d, a, b, d, e. So they were printed over here, and then the p values were printed over here, and the minimum key values and the minimum spanning tree key values were printed over here. So this is the code for the Prim's algorithm. Using Prim's algorithm, we have find out the minimum spanning tree. That's it. Thank you so much.